differential equation, ODE. Let me adjust the camera a bit so you can capture, the full width of the board, the space I would want to cover. This class was meant to have held yesterday by 8:35 p.m., but unfortunately network interrupted, and hence the need for us to hold the class today. In ordinary differential equation, today we are going to give attention to type 2 of ODE. Type 2 of first order ordinary differential equation. Please take note that from here at GMAETS 41, first order ordinary differential equation, I shall be using the acronym FODE for it. FODE, F-O-O-D-E, first order ordinary differential equation. As we move on in this class, okay, we are going to also treat second order ordinary differential equation, SODE. In our last class, I taught you the concept of solution of an ordinary differential equation. If you are given maybe a differential equation and you are given a function, how would you know that that function is the solution to that ordinary differential equation? So that I had already taught you. And in that class, I remember encouraging you to take the pre-recorded video lessons, okay, lectures on integration. I told you that integration forms part 3 of the introduction to ODE. I would like to say this, please, that without the without excellent knowledge of integration, it will be difficult to withstand this course. As a matter of fact, this is one key secret that scholars need to know about ODE before they move on into studying ODE. Please, I repeat, without integration, this course will be somehow complex to you. But with good knowledge of integration, at least in the aspect of first order ordinary differential equation, it becomes 1 + 1 for you. On this platform, GMAETS 41's channel, I already have video lessons that cover every concept about integration that you need. As a matter of fact, direct integration is type 1 of ODE. But I chose to leave that aside because I've covered that on several occasions. And I remember in your 100 level, for those who, in 200 level now offering ODE, in 100 level, you definitely have been introduced to the concept of integration. So please, once again, I am appealing to you, it's for your good. If you have challenges on integration, do well to take the video lessons on this platform. Slide through to Math 202 playlist on this channel, and then take the lessons on integration to include standard integrals. Standard integrals. I am emphasizing this because this is one area that really gave problems to students in this course. That's the truth. That's the truth. And not many educators might remember or even have the time to tell you as scholars offering ODE that you really need excellent knowledge of integration. It might be assumed that you already did that in your 100 level, so you should have the knowledge. But now I am emphasizing on the importance. So make sure you take lessons on integration. Standard integrals, yeah, there are about 7 to 8 functions. So standard integrals you're expected to know very well, because those functions you usually encounter them in ODE, okay? Then techniques of integration. Techniques of integration, that is methods of integration, to include integration by use substitution, integration by polynomial, integration by partial fraction, and of course integration by part. Once you are very good with these two aspects of integration, standard integrals and the techniques of integration, your problem in 4D is solved. Once again, you're welcome to this class. Now we have separable variable equation. This is type 2 of first order ordinary differential equation. Type 1, I told you, is direct integration. As you study ODE, another key secret that you want to always remember and be guided by it is your ability to identify the type of 4D you are dealing with. Because of course we have different types of first order ordinary differential equation as respect the methods that is used, the method that is used in solving them. The method used in solving separable variable is different from the method used in solving homogeneous 4D. It's different from the method used in solving a linear first order differential equation. It is different from the method used in solving nonlinear first order differential equation, the Bernoulli's type. It's different from the method used in solving exact differential equation. Therefore, a student of ODE is tasked with the responsibility of being able to identify the type of first order ordinary differential equation that you are dealing with. So what have I said so far as I introduce this course in full in our class today? Integration, you must have excellent knowledge of it. You should be able to identify the types of first order differential equation, because once you know the type, you will now know the method you apply. If I give you a problem and you don't know the type of 4D that question is, the truth is you can't solve it. Therefore, as we move on into this course fully, for each type, I am going to show you how you identify it. For each type, I'm going to teach you how to identify it, so that anytime, any day you meet any such question, you're able to identify it, you know what to do. A separable variable equation, which I am using SVE as an acronym for, is given generally to be something of this form. F of x1 times g of x2, g of y2, gy of 2, you know, and then dx plus f of x2, then times g of y1 dy equal to 0. This is the general form of separable variable equation. This is the standard form. Now, how do you easily identify this equation once you see it in a problem? The idea here is that you have a function of x, and this function of x is multiplied by a function of y. And then we have dx here. I am going to call dx parent that controls x, which means it is only x variable that can go with dx. If you have y variable with this dx as parent, you must, I repeat, you must find a way to remove that y variable, because the controlling parent here is with respect to x. Then you come to this. Please take note that this sign can be plus or minus. When the question is given to you, you can have this as either plus or you can have minus, separating the dx part from the dy part. Okay, then we have this, like I say, plus or minus as the case might be, f of x2 times, this point here is times, g of y1, and then multiplied by dy. The controlling parent here is dy, which means if the controlling parent is dy here, this differential coefficient tells us that only y variable can go with this dy. If you have x variable, you must remove that x variable from this term. You must remove the x variable. Then we have everything equal to 0. It is possible that the question is given to you, maybe this dy part is moved to the right hand side, so there will be nothing like 0 there. You have the dx part equal to the dy part. In either case, you want to remember what I've just explained as to how you identify this equation. Simply put, function of x and function of y are being multiplied. Take note, are being what? Multiplied, not added, not subtracted. Function of x and y are being multiplied, then controlled by a particular parent. In the case here, dx is the differential coefficient. And like I said, when you have this product like this, you must find a way to remove the variable that shouldn't go with the x. And what is the variable? Any variable about y must be removed from the controlling parent dx. Similarly, if you come to the controlling parent dy, any variable that is not y must be removed from there. And that is how you do the separation, giving it the name separable variable equation, which means a differential equation whose variables can be separated. I hope I've been able to communicate effectively how you identify separable variable equation. All right. Let us now get to learn how you separate the variables. I've told you why variables have to be separated, because of the controlling parent. The differential coefficients dx, dy, we call them controlling parent. Now, if you look at this part, you will agree with me that the controlling parent here is what? Is dx. So like I said, let me write general form of SVE. Look at it. Now, the controlling parent here is dx. Therefore, this gy of 2, this g of y2 must be removed. This means a function of y. So, how do I remove this function of y from here? It is simple. Here you use your basic knowledge of mathematics. Please, this is advanced level maths, ODE. If you still have challenge with basic mathematics, follow me on the GMAETS 41 basic class channel, where I coach pupils and students in basic level, right, on how to handle mathematical problems at that level, because you need this knowledge at this level also. Now, I have a function of x times a function of y. The controlling parent is dx. To remove this function of y, you have to divide this term by that same function of y. It's just like this issue of divide both sides by the coefficient of what you are looking for. If I give you something like 5x equal to 10, if you want to remove this 5 from here, because of course, this is a number 5, this 5 alone, it's like number, to remove it, since it is 5 times x, you have to divide it by 5, divide it by 5. So, to remove this function of y from here, you divide here by that function of y. And whatever you do here, you do it here also. Because like I said, this is an equation. And you know that in an equation, what you do to one side, you do it to the other side. So to separate variables, separating variables, what we are going to have is f1x times gy2, okay, dx, place what I explained here is the same as what you have to do here. You know, the controlling parent here is dy, so you have to remove this f2 of x, right? So we move on. This is divide here by g2y, okay, gy of 2, function of y2, okay? Another function of 1. Okay, then plus or minus, we have this f of x2 times g of y1. Controlling parent is dy equal to 0. I shall divide here by what I have here. Are you getting me right? Because like I told you, it's an equation. So what you do on one side, you repeat it on the other side. Okay, now with this, I've been able to remove this function of y from the dx part. Then go to the dy part. This f of x2 is not meant to be there. because this is a function of x, it should not be controlled by the parent of y. You know, therefore we shall divide here by f of x2. You are dividing because mathematically the sign between this function of x and these other guys is multiplication. So you do the opposite of multiplication, which in basic maths, the opposite of multiplication is division. So here, divided by f of x2. Look at it, f of x2. Which means you actually use f of x2 times g of y2 to do your separation. Whatever you do here, like I said, repeat it on the other side. F of x2. With this, I have done the separation. Please, I want you to take note of something, because once I am done with this, I shall now introduce you to the concept of integrating factor of a separable variable. Because in exam, an examiner can give you a separable variable equation and simply ask you what is the integrating factor of that guy. That is, what do you use to separate the variables? Like I told you, what I did here, I divided here by f of x2 and g of y2. So this f of x2 and g of y2 are the two guys I used in dividing. They are products. You know, you multiply them, then use it to divide the dx and dy part. With that, you've done the separation. When I cancel out, you will find out clearly that I've actually separated. If you observe this g of y2 will cancel this g of y2. F of x2 will divide, cancel this f of x2. If you look at this, this is function of x divided by function of x, carrying the parent dx. This is function of y divided by function of y, carrying the parent dy. So you've done the separation. Okay? You've done the separation. Bringing this down, we are left with f1 of x, that is f of x1, all over f of x2 dx, plus or minus g of y1 all over g of y2 dy, then equate to 0. You see at this point that I have this equation. It is only at this point that you can now do your integration. Remember I told you ODE, the first key thing you must be able to put yourself through very well, excellently, is integration. Once you are able to separate the equation, separate the variables, you can now integrate with respect to the controlling parent, with respect to the differential coefficient of that side. At this point, you couldn't integrate directly. Why? If I fix integration sign here, the controlling parent here is dx. It simply means I should integrate only x variable. That's the meaning of this dx. If I'm to integrate this term, you are integrating only x variable. The question now is, what will now happen to this y variable? If I integrate this part, the controlling parent, the differential coefficient is dy, which means I am only integrating y variable. So what will now happen to this x variable? That is why for separable variable, once the equation is given to you, normally you can't just integrate it directly. Except if in the equation, the variables are already separated for you. But I put it to you that the examiner won't do that. They will give you problems in such a way that you will be the one to separate the variables before you integrate. So GMAT 41 is telling you now that you can't carry out integration. You cannot integrate separable variable equations except you have already separated the variables. XX controlled by dx. Y variables controlled by y. At this point, you've separated the variables and then you can now integrate. So you fix your integration sign. Integrate this part with respect to x. Depending on the integration that can solve this, fine, you do it. And like I told you what to learn under integration, once you are done separating, it is either standard integral solves that problem for you, or one out of the 4 techniques of integration will solve that problem. You know, techniques of integration: integration by use substitution, integration by partial fraction, integration by polynomial, integration by parts. Any integration you want to do, one out of these 5 things I mentioned must work. Either that integration is done directly by applying standard integral, or the integration can be done by applying any one of the 4 techniques of integration. This is where my dear friend now have the work rather. Okay, this is where my dear friends have the work to do, because GMAT 41 will not be there with you on the D-Day to determine the technique of integration to use or whether standard integral can solve it. But what GMAT 41 has done for you is, on this platform, I have broken down integration. I have conquered integration 1 + 1 for you. You can access the video lessons, like I said, slide through to the playlist of this channel, locate my 202. So you go through, you would see the lectures, video lectures on integration, standard integrals, and technique of integration. Become a channel member so that you get access to some of these key lecture videos. We are done with this analysis, and you've learned how to separate a separable variable equation. You've learned how to separate the variables. Don't worry, when we pick questions, you'll see that. At this point, I now want to teach you the concept of the integrating factor of separable variable equation.